So we're going to look at properties of logarithms. We talked about the definition of a logarithm and going from the logarithmic form to the exponential form. Now, just to review, a logarithm is an exponent. So if we were looking at 7 to what power is 54, we could rewrite that as log base 7 of 54, and that would represent that exponent. So any logarithm is an exponent. Now, logarithms, as a side note, are really useful when you're dealing with extremely large numbers, like distances in a galaxy or some other big numbers, or really, really small numbers. Logarithms are very applicable in those situations. Now, on your calculator, you'll have a log button on the left-hand side. Hit log. It should give you a parenthesis, go 2 times 5. Hit equals or enter, and then go log 2, close your parenthesis, times log 5 to see if you get the same thing. And in this case, you don't. Now, you already typed this left side in, so you shouldn't have to retype that. Now, on the right side, type in log 2, close your parenthesis, plus log 5. Do we get the same thing? In this case, we do. Now, go to your calculator, type in log, it should give you that parenthesis, 100 plus 10, close your parenthesis. Enter. Now in the next line, type in log 100, close your parenthesis, plus log 10, and we want to know if those are equal. And in this case, they are not. Here, type in log 10 cubed, close your parenthesis, hit enter to see if it's the same thing as open parenthesis, log of 10, close your parenthesis for the log, close your parenthesis for the cubing, then raise it to the third power, and you'll notice that these are not the same. Now go ahead and type in these over here on the right hand side to see if they are true or false. So if needed, pause the video to do that. This first one is false. The second one here on the right does work. The third one on the right does not work. And the bottom one does work. So for the most part, when we look at these two right here, basically you cannot distribute the log through to what's in the parentheses. That's what we're trying to indicate here, that you cannot do that. Now, based on what's above here, if you have the log of two things to multiply together, like this one here, we should be able to break it apart into the log of the first one plus the log of the second one. Now, as a side note, remember a logarithm is an exponent. And if we are multiplying our bases, we have to add our exponents. So we're going to take the first exponent, because remember a log is an exponent, plus our other exponent when we're dealing with multiplication. Similarly with division, which ties into this one right here. If you are dividing, then we should be able to go log of the top minus log of the bottom. And that ties into dividing when what we do with our exponents. We have to subtract them. And once again, a logarithm's an exponent. So we take our first exponent minus our second exponent. Over here, that relates to this one right here. Basically, if you have an exponent after a log, you could put your exponent in front. Which should make sense, because if you have an exponent raised to an exponent, because a log's an exponent, raising it to a power, exponent raised to an exponent then, that we have to multiply our exponent. So we take our exponent of c and multiply it by our log, which once again is an exponent. And we had mentioned before, a little bit ago, that we cannot distribute your log through to what's on the inside. So this one here does not change. So with that in mind, let's try to apply those properties of logarithms to help us out here. So we are only told about our base of 5 and our power of 2, or not power, but of 2. So we want to somehow rewrite 250 in terms of only 5s and 2s. Well, if we do the prime factorization of 250, we get 5 cubed times 2. Now we have two things multiplied after a log, so we know we should be able to go log of the first one plus log of the second number. Now, as we look here, we like this purple part because that ties in with what we have here. So we could put that in. Now you got to think, okay, this is our base of 5. 5 to what power gives me a 5 cubed? Well, that would be 3. 5 to what power is 5 cubed? Is just normal 3. Now this one's pretty easy to add together in your head. Down below here, we have only a base of 6. We also have an 8, and we have a 32. So we want to somehow think of this in terms of either a 6, an 8, or 32. Now, for this particular problem, we know that to get 4, all we'd have to do is take 32 divided by 8. Now we'd have the log of two things divided, so we can go log of the first one minus log of the second one. Log base 6 of 32 is what we have right here, so we can substitute that in. Log base 6 of 8, that's what we have right here, so we can substitute that in. Now we have nice, neat numbers, so all we have to do is subtract those. More than likely, just type them into your calculator. Now, some of you might be thinking, well, I could just go log of 4 on my calculator. Well, your calculator does not go with base 6. It only goes with base 10. So when you hit your log button, that's base 10, not base 6. So looking here, we're going to go ahead and try to solve these two equations, and then there'll be a couple more on the next page similar to these. You'll notice on the left side you have a log plus a log. So we should be able to write it as one log and then multiply what's afterwards. So if you distribute that x through into our parentheses, we would get this. Now this ties into what we were dealing with the other day, where if you have only one logarithm, all you have to do is write it in exponential form, so you can take your base of 2, swing it over, hit your exponent up as your power, equaling to this. Now it's just a nice, normal, simple quadratic. And you know that to solve quadratics, you want to have it set equal to 0, and in this case it does factor quite nicely. So we could go ahead and factor it, and we would get this. But keep in mind that whatever's after your log, according to our definition, always has to be positive. We started out with variables after log, so we need to check our answers back into the original to see if they work. If we take -4 and plug it in here, it doesn't work because it would not be positive. So in this case, it's only the 2 that works. If we take 2, plug it in here, it's positive. Take 2, plug it in here, plus 2 is positive. Here, everything has logs, but you can't just drop the logs until you get to one log on each side. Here we already have one log on the left side. But on the right side, we have a log plus a log. Well, we have a property that says if you have a log plus a log, you should be able to multiply together what's afterwards. Now that you have one log on each side, it's similar to what we were dealing with a couple sections ago, that we can just drop the logs and then just solve it like normal. And then once again, you want to make sure that if you take this and plug it in, that you don't get a negative after your log. And by the way, this is positive times 3 plus a number is going to be positive, so it would work. So at this point, go ahead and take a look at these two and write these down. It's going to be very helpful. If not all things have logs, reduce it down to a single logarithm and then put it into an exponential form. If everything does have logs, reduce each side to a single logarithm and then drop your logs. Write that in your notes. So pause the video and try to work these out and then watch it. Try to get the left side to a single logarithm. We have a log plus a log, so we multiply what's afterwards. We have one log left, so we can write it in exponential form. Now it's just a nice normal quadratic. We set it equal to 0, and we factor it. And then we have to check our answers. Take our answers, plug them back into the original to see if they both work, because you have to, whatever's after your log has to be positive. Over here, we have a number in front of our log, so we could take that up as an exponent. We want to try to get one log on each side. On the left side, we have a log minus a log, so we know we should be able to divide those. Now that you have one log on each side, you can drop your logs and just solve it like normal. Multiply by 5, now take your fourth root, and when you take an even root, remember it's plus or minus. Now you want to see if they'll both work. And in this case, only the positive 5 works, since negative 5 would not work here. And you have to plug it into the original. If you plugged it into our second line, the plus and the minus would work because a negative to an even power would work. But you always have to check it into the original equation.